All right, hello. So I'm going to do a couple of the Chapter 8 review problems in a little bit more detail just to kind of go through the process. I encourage you to watch this and think about what sort of questions would you not want to see on the test, and then make sure you ask me to make a video. I know, I think that the differential equations were the hardest for many of us. So I'll do a couple here and then make another video doing a couple other ones. So let's look at part A. It's written maybe backwards. I'm just so used to having my derivative on the left. I'm just going to switch it around. Makes me more comfortable. So then I have xy over x plus 1. Divide both sides by y because we're going to separate, and then we're going to integrate. And so I've multiplied by dx. The left side becomes natural log of the absolute value of y when you integrate it. And the right side here is one of those little weird u substitutions where the denominator is linear. So you say u is x plus 1, du is dx, and that means that x is u minus 1. And so you can rewrite this even, I haven't done my integral yet, but I can rewrite it as u minus 1 over u du. And I can further rewrite that as a fraction or as the sum of two fractions, because when the numerator is linear, then you can split it up. So it's just u divided by u minus 1 over u du. Integrate that, we get natural log of absolute value of y equals u minus natural log of the absolute value of u. A couple options for how you can proceed from here. Well, we better get a plus c on there. I'm just going to exponentiate both sides. You could do some other things if you want, but I'll just exponentiate. So I have absolute value of y equals e raised to all of that stuff. And I'm going to just drop the c in front. That's pretty standard practice. So c to the u, or e to the u minus natural log of u. And so if we simplify that, we have c e to the u. And when you have a negative exponent, you can make that into a division problem and then cancel out the e with the natural log. So now we're here, and let's just get it back in terms of x and y. So c e to the x plus 1 over the absolute value of x plus 1, like that. And if we had some sort of initial value, I'd be able to determine if we have the positive arm of the absolute value or the negative arm, but that's our general solution right there. So that's part A. Part B looks to me fairly similar, except for part B, the u substitution for the denominator, x squared plus 1, will cancel out the numerator even a little bit nicer. So there you go. I'll skip part B and I'll move on to part C here. Of course, if you want me to do part B, just ask, I'll do it. But here's part C. We've got 1 plus xy prime equals y squared. Always a good idea to get y prime by itself. So I know that y prime equals y squared minus 1 over x. So I subtracted 1 and divided by x. And this is actually separable. So if I divide by y squared minus 1, I have dy over y squared minus 1. And if I multiply by dx, I have dx over x. I'm going to do a quick sidebar because y squared minus 1 factors to be y plus 1 times y minus 1. And when it's factorable, you can split it in partial fraction decomposition like that. So 1 equals a times y minus 1 plus b times y plus 1. Substitute positive 1, and then you get that 1/2 is equal to b, because b was multiplied by 2. If you substitute negative 1, it cancels out the b term, and you have that negative 1/2 is equal to a. So I'm going to grab that in order to integrate the left side, including the y's. I now know that the left side can be written as negative 1/2 over x plus 1, y plus 1, and then positive 1/2 over y minus 1, dy equals dx over x. And now we integrate. So we have the negative 1/2 times the natural log of absolute value of y plus 1 plus 1/2 natural log absolute value of y minus 1 equals natural log of absolute value of x plus c. I'm going to go ahead and erase my little partial fractions decomposition. Get out of the way, get out of the way. And I'm going to take this and just do a couple moves to find the general solution. Now we know that you can combine natural logs together, and this left side can be rewritten then as, and you can also bring the 1/2 up as a power, which is a square root then. So you can rewrite the left side as the natural log of the square root of y minus 1 over the square root of y plus 1. Oh, that's weird. Y plus 1, there we go, equals natural log absolute x plus c. We're going to exponentiate both sides, drop in the c down in front, all that fun stuff, canceling out the natural logs. So now we have absolute value square root y minus 1, square root y plus 1, cancel out the natural log, so we have c times absolute value of x. We can do a little bit better, because when you're dividing two square roots, you can combine that into one fraction. And in fact, because it's got the square root on it as well, we know that it's a positive value. So we can get rid of the absolute value bars on the left side. So we have y minus 1 over y plus 1 equals c times the absolute value of x. And here's a nice thing too, because the c value has yet to be determined and the absolute value is either going to be positive or negative, we can just drop the absolute value on the x as well. And so where do I even have real estate left? Let's try to draw a little box right here in the middle where I'll go. I'm going to square both sides. I can just still call it c. So now I have y minus 1 over y plus 1 equals cx squared. Then we're going to multiply by y plus 1. So y minus 1 equals cx squared times y plus 1. I'm going to do a couple moves at once. I'm going to get my y's all on the left side and distribute it out. So what do we got? We got y minus cx squared y equals cx squared plus 1. And then factor out and divide. So y equals cx squared plus 1 over 1 minus cx squared. So there you go. And you should go back and double check, if you do take the derivative of that, does it actually satisfy our original differential equation? So you'd use quotient rule on that and see if plugging it in works. This should be the general form of the solution. So thanks for watching. Ask questions. Let me know what else I can make for you.